Hello and welcome to today's Teardown Sessions. I am extremely excited to tell you that we've got absolutely loads of blinking lights and LEDs to show you today, maybe even a little bit of live code as well. Today's guest is Connor from Lixie Labs, who did the fantastic Pixie Chroma, which is a chainable RGB LED-matrix, and we're going to be taking a real close look at some of their work today. I think we've got some really exciting previews of the stock that's coming in. I'm excited to hear how manufacturing is going. But before that happens, first of all, I wanted to tell you that we have, as usual, our box of mystery hardware that you can win. All you need to do to win this box of mystery hardware is comment, and the person who comments closest to the timestamp on this post-it note will win the contents of this box in any country that we're allowed to send it to. So please do keep your comments coming in and your questions for the creator, because it makes us feel a little bit less like we're yelling into the void. Okay, so before I bring on Connor, I would like to share a couple of the things that we're doing at Crowd Supply at the moment. So live at Crowd Supply at the moment, we've got Arduino, which is a CAN bus prototyping platform, in a very nice nice case, nice milled case, and you can do all sorts of great things with that. So if you're into car hacking and you want to prototype your own product, then you can do that with Arduino. Got 2 weeks left to support that. Also live at the moment, we have got the latest in the range of ink plates. Ink plate, as many of you may already be aware, are open source hardware, Wi-Fi enabled e-ink tablet things that have been, they're actually, many of them are reused Kindle screens as well, so removing things from the e-waste, which is great, and they're obviously doing well because everybody loves them. We love Inkplay. 6 days left to buy this one at this price. This one is color and it's 6 inches, or nearly 6 inches as well, so definitely check that out if you're interested in e-ink display. Another thing that's live at the moment, just gone live actually, is the Mango Pi Naser MQ, which is very exciting for those of you who haven't been following the rise of RISC-V in electronics. This is your chance to get playing with this exciting new technology. Definitely really, really cool little dev kit here from Mango Pi. So really, I'm very excited about that one. And then it's really great to see some RISC-V come to market, you know, very exciting movements. All right, so also coming soon from Crowd Supply, we've got this little adorable thing. This is the Loco. It is a tiny open source long range GPS tracker designed for drones. So you put the little one on your drone or whatever it is that you want to track, and then there's this base station, and then you can find it wherever it is on your phone. Fantastic. If you're into drones, I would definitely recommend you check this out. And of course, it is open source too, so we're spreading the knowledge. So yeah, that one's coming soon. Sign up for updates on that if you're a drone lover. And then finally, the last thing I wanted to show you that's coming soon is this lovely little plain DAC, which is a very simple, cute little DAC module designed for the Raspberry Pi Pico. So check that out. Finally, if you are local to us, and that's in the Pacific Northwest, we're here in Portland, I'm hosting a hardware happy hour beginning at the end of March. So if you are local, please go on to Meetup and sign up. If you're not, it's all outdoors, vaccine compulsory for the bar to go in. If you're not comfortable this month, we're going to continue doing it further into the summer, and we'll always do it outdoors as well. Just come along, have a beer with us, show your projects. It's all very informal, no presentations, just a nice time. So if you're local, please consider coming along to our hardware happy hour. Okay, so without further ado, I'm very excited to bring on the lovely Connor from Lixie Labs.
Hello everyone. Connor. Hello, Helen. Hello, everybody. How's it going?
Why don't you introduce yourself and get started?
I'm Connor. I am the engineer of Lixie Labs. My partner Holly, who's not here right now, she's at work. She does a lot of our just kind of logistics and management. She's lovely. And our product on Crowd Supply that was successfully funded was the Pixie Chroma, which is a chainable RGB LED display. that is currently like less than 10% brightness so that it doesn't just blow out on the camera. It's very simple to code for, and I'd be happy to show that off later.
We're going to do some live coding. I'm excited. I love it when people come on and do some live coding, so it's exciting. But first of all, we're going to come on and say hello to the people who've joined us. Hello, Team Monsku. Nice to see you here. Then Jason Kuhn from Evil Genius Labs says hello, Helen and Lixie Labs. Hi, Jason. Nice to see you. Thanks for turning up. And Kevin Freitas, I hope I didn't butcher your last name too badly there, is a first-time viewer and is very excited to hear about your character matrix displays. Well, lucky for you. That's what it's going to be. Kevin also said that the tracker looks fab, doesn't it? It looks great. I love it. I love the red as well. I like the choice. And then we got Deshipu, who said, Gute Abend. Hi. Hi, I'm guessing you're in Germany, so good evening for you. And oh, excellent! I got the last name right.
Nailed it. Cool.
Good, nailed it. And Kevin also said, could you host a Seattle meetup sometime? I actually did last year, and there is a Seattle hardware happy hour in existence already with all sorts of really exciting people in it. Sophie Wong goes to it, Amy Double D, and Eric Moyer as well. And of course, you've got Jeff from Mighty Ohm in Seattle who goes to the Seattle hardware happy hour. If you look on, there's a hardware happy hour Discord server, and they post stuff around that. I'll drop the link later. So yes. Oh look, and Lady Lixie's joined us.
Hey, you?
Hi. Nice. That's really sweet. Really awesome to see you. Great, fantastic, awesome. And Tima says that they're very cute looking modules. I agree. So why don't we start off by tell me a little bit about the actual modules themselves. Tell me a little bit about what they do, why they're cool, and how you code them. Yeah.
Pixie Chroma is a little 30 by 24 millimeter board with 70 RGB LEDs on it. And these are actually, if you've ever used Neopixels at Adafruit, any of the WS2812B compatibles, these are just a little 1515 package version of those. So it's only one data pin to control all 70, technically 70 times 3, 210 sub LEDs from a single pin on your controller. So you get like 5-volt ground data in, and then a 5-volt ground data out on the bottom to the next one.
So they're chainable, really just like fantastic. Look at that. So they're just 3 pins, and the pin on, you only need like 1 pin on the microcontroller. Did I hear that correctly?
Yeah, that's just
fantastic.
Work out my camera here. That one right there, the yellow one.
What microcontroller are you using?
That's a Wemos D1 Mini. It's a ESP8266 on the back of that.
Oh, okay. I've not used that.
Yeah, they're real tiny. I like them.
Yeah. That's my sense. Very cool. So it's just one wire, data in, right? I mean, data in, no, not data. So it's data in one end, data out the other. So basically just the same as chaining up some Neopixels.
Oh, exactly. Cool. So if you've ever hooked up a Neopixel strip, it's kind of just a glorified Neopixel strip with some, all the values and how easy the code is and how cool the hardware is.
Yeah. So why don't you tell us a little bit about why you decided to put 70 LEDs on one board?
Oh,
what's it for?
So, thank you for keeping me on track there.
No.
So there's 2 halves, if you can see here. Each one is 5 LEDs by 7, and that's kind of the bare minimum to get a full alphanumeric set of characters that are really readable and easy. And I don't know, I lost my train of thought there.
So you're basically you wanted to make a shiny Neopixel-esque way of writing text.
Yes,
text and emojis.
I could go into our background a little bit. I wish I had one to show off right now. But in 2016, I sold what were called Lixie displays with an L. Very confusing naming convention, and I'm sticking with it. So Lixies it was 10 panes of acrylic, each edge lit with LEDs, and they had a numeral on them. So just like a Nixie tube has a stack inside of it. These are like a 5-volt, low voltage version of nixies.
So that's where the name comes from. So it's like an LED nixie.
Yeah.
I was okay.
At this point, everyone calls them lixies. I've seen a lot of makers make different ones and call them lixies. So that sold very well. That basically helped build us up as a company. And a few years ago,
that was your first project?
Not my first one. I had some home automation stuff for Raspberry Pi, but I was really new to it. It was a little kind of hacked together,
Yeah, it was experimental.
Yeah. So I have a PCB here. The original Lixie PCB just had 2 LEDs for each pane. And then a pretty board on the back.
Spotlighting you so we can actually see it. Oh, nice.
And then
Open Source Hardware Association, I see on the back there as well.
Oh yeah, so that was US
certified?
54. I was kind of early on that.
That's early days. Yeah.
That sold well enough that it kind of took it from being a hobby for me to being a business. And then I think it was 2019. I used my 3D printer and I made a little plaque for us because we sold 1,000 units. And
that's awesome.
Just this month, I got to make a new one.
Show me.
Right over here for 3,000.
Yeah.
And some Pixie Chromas mounted on the front there with a little kind of circuit sculpture on the back.
Oh, that's delightful. That's really nice. I'm glad I feel like we should celebrate ourselves more. I'm glad that you're giving yourself some snaps, some pats on the back for the sales. Because 1,000 and 3,000, those are quite big milestones. Well done. I have got a couple of questions from the audience and comments. So All Sployd says, super fancy. How much power do they consume? I guess that depends on how many you're using. But yeah, let's have a little chat about power consumption for this.
There's actually a really cool answer for that. Let me get a calculator real quick. I'll just do it on my phone. So I think each of these LEDs at full white does 60 milliamps, but it's like blinding white. You don't have to do it that bright that often, but 60 milliamps times 70. So at its maximum potential, it's going to be 4.2 amps per board. But think of these displays here. Most of these LEDs are actually off. Only a select few are on at a given time to show a message. But the coolest part about Pixie Chroma, it runs on the library FastLED in the background. And FastLED has a lovely bit of code in it where you can set a power budget. So there's
nice. I didn't know that.
Yeah, so FastLED, and it's like the longest function name ever. FastLED.set max power in volts and milliamps. It takes 2 arguments. One is your voltage in like a floating point, so you can do 3.3. And then your milliamps, if you want to limit it to like 500 milliamps, let's say, so it's like PC USB safe, you would put in 500 milliamps there. And what FastLED is going to do is in the background, it's going to take a look at what you're trying to send out, knowing how much power it could take based on, some research and some hard-coded values. And it will globally dim the whole thing if it needs to keep it within that power budget. So Pixie Chroma, since it runs on FastLED behind our own library, we just took that function and brought it to the front again. So you could do pix.setMaxPower, a lot shorter function name. And then, 5 volts, 2,000 milliamps or 500. So that's way, amazing. You can have a huge long chain. And as long as you have that line of code in there that says, hey, don't go over, an amp, it will never let you.
That's fantastic. I've used FastLED a few times. I'm like, I didn't even know that functionality existed.
I found that
I've definitely, it's so useful.
I found that way down into the code. It's there.
Timon also said, that's so nice. I was not aware it had that function.
Yeah.
And Ospoloid said, nor was I. Awesome. Super
FastLED
cool.
has really good documentation. Like if you want to go into like all of the code pages for it, but like the examples that come with it, they don't show off because there's just hundreds of functions. It would just be piles of examples to show all of it.
Yeah, no, really awesome. That's great. Got another question here as well from Kevin saying, how do they look behind a dark tinted plexi or even a thin layer of ply or plastic? Yeah, have you done lots of diffusions?
Yeah.
Have you experimented with diffusing them?
I was going to actually. This little white piece of 3D printer filament before this crapped out on me, and I bought a Prusa Mini over there.
Seriously, I've got 2 Prusa Minis on my workbench at the moment at home.
Lovely.
Yeah, only one of them belongs to me, sadly.
Printer. It just goes.
No, exactly. It literally just works. I do live my Prusa Mini, that's for sure. But you've not tried it. You've not done much with diffusion yet. I think that's. I'm very excited to see what the community does then with diffusion. So that's cool. Oh yeah, that looks good. Oh, that looks really nice.
And that's 10% brightness on these. They're very dim at the moment.
Yeah, but that, do you know what? I think that would look gorgeous behind dark tinted plexiglass.
So. Yeah,
I think it would look. I do love I do like a tinted diffusion shield. Beautiful. We've also got a question from Timon saying, how many modules can you reasonably daisy chain before refresh rate tanks? Good question, Timon.
That is a really good question.
For asking it.
So these LEDs and pretty much all of the compatibles, like the Neopixels, they run, I think it's 80 kilohertz is their data rate. And you're limited to that. You can't go any faster or they won't read it. Because these aren't LEDs that have like a data and clock line where you can cheat them a little bit. So they're very timing restricted. So when you need to do a really long chain, like this one here could run, like 60 frames a second. But if I wanted one like 4 times as long, you can still do it at 60 frames a second, but you just use 4 GPIO in parallel. So like your first quarter of the display comes from 1 GPIO, your next quarter comes from another. So let me grab I'm gonna take my headphones off real quick. I'm gonna grab something I'm working on right now.
That's good. While you do that, I'll share some of your links. So if you're interested in this, is you can go to crowdsupply.com/Lixie Labs Pixie Chroma to pre-order. Or if you want to follow along with what Lixie Labs are doing, you can check on their very active and very personable Twitter, which is Lixie Labs, or Lady Lixie Labs as well. They're both out there, so do go for them both a follow. You'll also find your the code base on the GitHub as well. So do I'll share those links again later. Go on, show me your. I'm going to spotlight you again so we can actually see you better.
So work in progress. I took it apart slightly for this live stream, but I'm just building up a huge chain of these right now. This is like probably 3 or 4 feet long to do more testing with the high-speed modes and just see how crazy I can get. Because you can also do multi-row displays with these too. I don't have that demoed right now.
Yeah. Very cool. Very cool. Okay, so good stuff. Oh, Timon's got a follow-up question saying, does your library account for doing this sort of multi-output? This might be a good time to start to should we use this as a segue into talking about your library, because that's one of the things that is most impressive about what you've been doing with these Pixie Chromas is I hear that your libraries are particularly exciting. So why don't you walk us through some of the highlights?
Yeah. So
do you want me to? How do you want me to do that? Do you want me to bring up the GitHub page, or do you want to? Why not? Do you want to do share screen? Do you want to put it yours up, or?
Sounds good. Let's do that.
Okay, fine. I will add you to the screen, and let's have a little look at the libraries and some code. Why not?
Okay, so can you see me? Can you see my screen?
I can see your screen and I can see you. So I can see the Arduino screen. I can't see.
Okay, good. So
yeah, all I can see is an Arduino IDE window.
So I'm gonna get back to the question about how easy it is to do that multiple GPIO thing, but we're gonna take a look real quick at the code that was running on the breadboard you saw that was lit up that says crowd supply.
Yeah.
So this is all the code you need. This first line up here, you just include the library, get an instance of the class, you can name it whatever you want, and define what pin you're going to be using for data, how many pixies on your x-axis you're doing, so how many pixies wide is your display, and how many pixies tall. So in this case, we've got 6 wide and only 1 row, so we're only 1 tall. Pix.begin helps set up that power budgeting stuff. That power budget actually defaults to just 500 milliamps to keep everyone safe, no matter what. And then you can manually go in and increase it. So this Pix.begin, if I just do Pix.begin quad, and then instead of my data pin, just say, how many pixies are in each quarter, then the ESP8266 or the ESP32, they have, unfortunately, it's hard-coded right now which pins it uses, because there's some very fast pin switching tricks. So we don't get to choose our data pin anymore. But now it's already in that quad mode I was talking about, where you can use 4 GPIO at once. So that's the only change you would need to get that done.
Awesome.
Beneath that, we're setting brightness. So this is out of 255. You can see just how low I have the brightness set, so it shows up on camera. And I think the first thing we'll do is just change this to 255.
Yes.
Let that upload in the background.
Let's see the difference.
So Pix.set palette. I'll talk real quick kind of about how Pixie Chroma does color and how it renders to the displays. So there's 2 layers. There's a color map and a mask. So the color map, think of it this way. If you've ever seen those craft papers that are black and you scratch at them and there's rainbow colors underneath it, it's kind of like that. So your color map currently on here has a big rainbow going across, and your mask is it's like the stencil that goes over it that has the shape of the text. So that way you can move color completely independently of your font, and you can move your font completely independently of the color.
That's a really interesting approach.
So my palette right now on the screen here is set to a preset called rainbow, just red, green, blue, back to red. And then Pix.clear just internally clears the display buffer, sets everything black. And then Pix.print with the word crowd supply. And Pix.show is just like FastLED. It sends it down the line and you see the updated text. And that's it. And the loop down here just has a yield, so it doesn't crash because ESPs are interesting. So let's take a look at our updated brightness here. Let me come back to Chrome. So here's 255. Yeah. It just shows up as white. You get the essence of the color, but let's put it with that diffuser, so a little bit darker.
Yeah, that is super bright. That's awesome.
So, one of my favorite things about how we set up this library is it is just as complex as you need it to be. So if you're just beginning and you just want text on it, it's like 3 lines of code. But you can go in, it's almost like writing shaders. You can get really complex with UV coordinates on where color goes and how animations work. And you can make it run with an ISR in the background, so you don't have to call show. And you can use delays, and it'll still keep the displays up to date while the delay is running.
Where have you how have you approached doing the documentation for something with such complexity?
Yeah, if you want to,
yeah, sure. I'll share the screen again, but it's showing me at the moment. Wait, no, up to stream. Here we are. Look. Ah. The backstage. Right.
So here on the GitHub, one of the things we could talk about is just how much I've automated. I have a billing problem in my account, I know. How much I have automated away a lot of the documentation stuff. So
interesting.
If I click on this link up here, Holly and I just call it the pink site. We get to the pink site here, and this was not manually written out. This was generated by a piece of software called Doxygen. So the way Doxygen works, so if we go
writing that down immediately.
Let's see. Let's go to the internal CPP file. Okay, so there's a lot of comments in this file, and they have special syntax like this. And it says what, Pixie Chroma .set palette does. It accepts a FastLED CRGB palette 16 object to set the current color palette for animation. And then one parameter named pal that does this. So what Doxygen does is it looks through all of your code and creates a website with the documentation in your comments of all the same stuff. So here is that set palette that we just saw. And we can jump to where in the file that is. And so that was really helpful for getting like a really thorough documentation site. And you can actually, in Doxygen, you can write your comments in Markdown, just like you would on GitHub. So I can do like these formatted
no way, that's great.
Bold and bullet points.
Yeah, fantastic.
And then the GitHub, I don't think there's any private information to this. We have automated workflows that happen whenever we commit a change to the GitHub. So this Arduino build here, what it did was whenever we push a change, it's going to compile all of our examples for ESP8266 and ESP32 currently. And if anything fails to compile, it will let us know.
Interesting. That's a really interesting way of doing it. I like it.
So kind of a highly automated documentation.
Very cool. Right, I've got some questions and comments here. We've got Kevin has said, would be fun to see these behind a frosted white plastic. I agree. Would make a cute alarm clock for our kiddo. Maybe with some fun buttons he could use to interact with, colors or emoji. Yeah, would look at. I think that would be great. Also, a question from Kevin saying, have you got any plans to allow printing text or characters via an HTTP or other API? Or is it just hard? Can you just hard code it now, or is it just you have to edit in Sketch, or is there another way of sending?
Yeah. So currently, one of the examples I have in the library is to basically use it as a physical serial monitor. So that any UART connected to it, all the stuff will actually just show up on the chromas. And then what you could do, because the ESP8266 or ESP32, they're all Wi-Fi, you could probably just do like UDP packets that get sent off with what to show, or over the internet. Yeah, you could host, you could open a port on your router, which is, that's up to you.
Have you seen what Ben Hank does for the Pixelblaze? Have you used the Pixelblaze?
I haven't. I watched a little bit of that stream the other night, though. I didn't realize it ran on an interpreter.
It's such. I mean, honestly, like I've really enjoyed using the Pixelblaze, but it's just such a novelty that I can access it from my phone. It's like a Wi-Fi hotspot, and then change the code on my phone. I'm like, oh, this is so fun. No, I'd recommend having a look at Ben's work. Maybe when you come up later in the year, then we can get you to meet up with Ben, and we can see what LED wizardry would commence if we got Lixie Labs and Ben Henk in the same room. I would like that very much. That's cool. We've got, here we are. So does the library support other MCUs, or is it currently optimized for the ESP8266? Well, actually, I've got a little question on top of that. I was wondering why you chose to base it on the MCU that you chose to base it on. Like, why are you using ESP32, 86, you know.
So
Yeah.
I started it first. The very first version of the code ran on ESP8266. And currently, it doesn't actually run on any 8-bit microcontrollers. And the main reason for that is just RAM. There are, you know, like in this panel alone, if you wanted 6 Pixies, it's 420 LEDs. So 420 bytes times 3 in your RAM. And that's just the LEDs themselves. We do that thing where we have the color map and the mask and, you know, a couple other advanced features. So it's definitely like, you know, a next-gen microcontroller kind of board. I am planning to do sort of a PixieLite library, so it's still compatible with the other boards, because I have some tricks in mind for how to get around the RAM issue.
But what would this PixieLite, what are your aims for this PixieLite, and what kind of thing would it run on?
Oh, yeah. So like PixieLite, theoretically, I got to start on it, would run all the way down to like, you know, an Arduino Uno. And
wow.
you would probably, to save on RAM, we would never actually keep all of the LEDs in memory. We would only keep what character is on each one, and maybe 1 or 2 colors for the whole display. Not necessarily per pixel color, but entire display. So you can still have like red text, green text next to each other, maybe some gradients. And then what we would do is just render it out to the LEDs in real time. Don't actually keep it in RAM. Calculate the bits that need to be sent to each LED in real time every time you show it. So that way we're only dealing with like 3 bytes at a time.
I see that.
For the color.
And for that kind of thing, I mean, would you still keep it Arduino based, or have you considered, for example, porting it to CircuitPython on, you know, like a SAMD?
I gotta learn CircuitPython, MicroPython. I'm so behind on that.
It's it might work for the light well anyway. So actually Timon also said that the RP2040, which is basically it's available. You can buy the RP2040. Like that's why we've got so many projects with RP2040 is readily available on the market. Or SAMD would be interesting. I agree. And he also said that it's totally fair. The 8-bit era is really over. Controversial.
Yeah, there's still plenty of AT-Tinies.
There are.
You know, AT-Tinies are great still. But the main reason why, so currently it's only on the ESP32, the ESP8266, and the teensy 3.0 or 3.1 line. Maybe the 4.0, I just haven't tested it. It might work just fine.
Well, you know, Teensy's a Portland people as well.
Oh, I didn't know that.
Paul's a Portland resident. He's another local hardware. There's lots of us around here.
The
that's
main
cool
reason we're locked to certain microcontrollers currently. So, like, I would do the RP2040, but last I checked, FastLED doesn't actually have a port, an official port for RP2040 yet, which is one of our dependencies in the library. So I'm kind of waiting on that because I'd be really excited to do an RP2040 one.
Yeah, I mean, actually, there's another person in the comments who's talking about the RP2040. Osborne says it would be really cool to be making. Yeah, exactly. I've not really done anything with the PIO, to be honest.
I haven't either.
I've read about it, but I'm in the same boat.
Because that whole thing on my list of things. Driving tons of displays in parallel would be really awesome if we could do that with the PIO. You know, like 8 6-long chains of Pixie Chromas all on one little microcontroller.
Yeah, that'd be super cool. Team on here again, like smack talking 8 bits. 80 tiny costs more than a SAMD 09. I don't see their point anymore. That's fair enough.
Actually, the SAMD 21 was actually going to be one of my targets for this, but I can't get them. The SAMD 21, SAMD 51, they're just They're so low on inventory right now. I just focused.
Yeah. You gotta basically stab somebody to get a reel, like, and steal it. You know.
I'm so glad that like espressive boards and smart LEDs haven't seemed to have been affected too much by the global chip, shortage.
Yeah. I got another question here as well from Kevin saying, would the Pixie code work if I set up my own modules arrays using Neopixel strips or strands? I don't imagine you've tested that, but theoretically,
I haven't, but yes, it should. So the way these work is they're reading order like a book. So you go top to bottom on your left page, and then top to bottom on your right page, left to right in each row. So the same way you would read a book, an open book, is how you have to lay out your LEDs for it to match up.
Oh, very cool. So Timon's also said, like, it's sad how hard microchips are to get at the moment. And also that SAMD 11 with USB is similar price to the AT Tiny. So, well, interesting. Okay, so I would really like to take some time to learn a little bit about you and Lixie Labs and, what got you started? Have you got an engineering background? Like, what's the deal with Connor? What's the deal with Lixie Labs? Tell us about yourself. And why are you interested in open source hardware? I'm like curious.
Oh yeah. So I went to school for graphic design. That was my trade, and I still get to use that, even though I didn't want to do it as a career. But while I was there, my best friend, 10 years now, I met him there, and he told me there was this computer that was the size of a credit card for like $30. And I was like, oh wow, can I game on it? I didn't really know anything yet. And he's like, no, it's like a project thing. It's called a Raspberry Pi. So he let me borrow it. And I took it home. And one of the first, little examples you would do with it is turning an LED on and off.
Yes.
And the moment I did that, pseudo LED, whatever one to turn it on, and it comes on in real life, it just stuck with me. Because I coded for websites up at that point, but that's all behind the screen. It's in a whole different universe. On the atomic level, something just changed in the real world because I did that.
I had the same experience. I coded for web and I was like, okay, fine, do a little bit of PHP, not really bothered. Instant, I turned an LED on. I was like, oh my goodness. And now I want to code.
I got a tattoo of that LED, and she's got the resistor to stop mine from burning out.
We got matching electronics tattoo represent. I love it.
So from there, I start to learn about. I get really interested. I find Hackaday around that time, and I got into this habit that. And maybe some other people do this, but every time I get a new thing, I'm like, ooh, ESP8266. I go straight to Google and like, ESP8266 hack. Like, what's some cool trick this does? So I started to do things like adding analog audio to an Arduino Uno with no parts. So it doesn't have a DAC on it. It just has high or low. But if you do PWM in an ultrasonic speed, the speaker can't physically keep up. So it actually, the cone of the speaker, you now have analog control of the cone with the PWM. So that got me into this habit of like, what is the most I can do with the least amount of hardware? How far can I push everything? And I think that's stuck with me to this day.
That's really awesome. And you said you started off by creating these LED nixie products, and then moved on. What made you? This is your first crowdfunding campaign, right? So you were selling before on Tindy, I imagine.
Yeah.
I mean, I know you work for some of the stuff, but like, have you always been a Tindarian?
I've been a Tindarian since like 2015.
That is what you call them, right?
I'm pretty sure. Yeah.
I've heard. I'm friends with Jasmine from Tindy, and
Jasmine's lovely.
She's delightful. We love Jasmine. Big up Tindy. We love Tindy. yeah, it's and what made you decide to think about crowdfunding? Like, is that something you had in mind before, or?
I think so. A lot of the products I've made before, like the Lixie displays, they're really big. They're kind of fragile. There's a lot of work that goes into each one. But things like the Pixie displays, when I started making those, Pixel Lixie, that's where that name came from. They're a lot more simpler hardware-wise. A lot of it can be done by machines, whether it's my own or a vendor. And at that point, I started to get a lot more comfortable with the fact that with the idea of ramping up. Because if I crowdfunded a bunch of acrylic displays, I could do it, but it would be a lot of work. And we're not quite there, like, Holly and I, not quite there mentally to take on that challenge yet. Whereas like Robin Ryder, who's doing the Pixel Pump, he's got a lot of hardware to do, but he seems like he's got people, he's got a little team going. He's got little cloth tags on those. They look like remotes.
His production standards are amazing. Like every time I see his stuff on Twitter, I'm like, what, Robin? Oh my God, yeah. He's really like pushing the packaging. Have you seen his packaging? Oh my goodness.
Yeah.
He's getting it done.
Like a laser cutter with cardboard. They're all folding right.
He did. Yeah. Very impressive. Very
impressive. Pixie Chroma, let me find an original Pixie board. Let me grab one real quick.
Oh, yes, please do. Very cool. Again, I'm just going to share the GitHub repo so you can have a poke around the code and read the docs, the beautiful pink docs that we saw earlier. And if you want to pre-order, you can go to crowdsupply.com and find Pixie Chroma and place a pre-order for that. I think the pre-orders should be coming in fairly soon because on Twitter, so Lixie Labs have got a fairly active Twitter, and I've been seeing pictures of jigs, adorable little jigs, and lots of boxes of boards. So I do believe that we are well into manufacturing. So that's pretty exciting for us. Do keep your comments coming in. I'll do them in batches as we progress. Okay, well, here we go. So I suppose let's just wait for Connor to come back, unless you've got anything. Do you want to ask me? Oh, here we are.
Hello.
You find it?
Okay, so I don't know where a populated Pixie board is right now, but
it's okay. We can use our imagination.
For anyone who doesn't know, the very first version of Pixies used two LTP305 displays, which are these kind of vintage 5x7 micro LED displays for like calculators and stuff. So on the back of it, we had an AT-Tiny right there, AT-Tiny 45, and this IS31 FL3730, I think, is the chip name that did the LED matrixing for us there. And each one of them had firmware that we had to flash on each one manually.
Wow.
And then all of a sudden, I couldn't get these 3730 chips anymore because of a current event going on. And it started to really drag on us. So I just kind of went back to the drawing board and I realized, wait a minute, those LEDs I used to use on Lixie, they're not 50-50 anymore. They're like 15-15. You can get them so small.
Yeah, the teeny weeny.
So it's slightly larger than the older models, but that's where Pixie Chroma came from. No microcontroller to have a shortage of. It is
well, that's one approach. That is one approach.
LEDs.
Yeah.
I just kind of had to switch over. I had to pivot. So here's the back of the PCB, by the way. Here's
I guess that. Nice.
ID.
Oh, actually, there's a question that links with this actually, which is Allspoy said, great example of your graphic design skills on the back of the original Lixie board earlier. Any other cool PCB artwork you can share? I will say that I'm not surprised that you went to school for graphic design, because everything looks gorgeous. You know.
So yeah,
hang on. I've got also a question. I got a comment from Kevin saying, "Ha, no microcontroller, no problems." That's true. But also, Kevin, that means that you commented closest to the timestamp, so you win today's box of mystery hardware. And actually, I think you said you had a kid earlier, which is very exciting, because we've got some kid-friendly electronics in here. So I'm quite glad that you won. So let me just show you what's inside. First of all, we've got a very exciting and fetching Mauser baseball cap. We've got a Circuit Playground Express, which is a fantastic little Ada group. They're fantastic, and they're great if you've got a kid, so that's perfect. We've got
I got like
a whole
20 of those at Radio Shack when they closed.
I've got so many. So these are fantastic little boards for learning. Honestly, they're my favorite education board. That and Microbit. We've got a whole bunch of Corvo RF enamel pins in there for you. Some stickers. We've got more Crowd Supply stickers. And then we've got this, which I'm kind of excited. I'm kind of jealous of. Something called a Circuit Scribe, which is a pen with conductive ink inside. So you can draw circuits with little stickers with LEDs on them as well. So Kevin, please DM me, Crowd Supply or Helen Leigh on Twitter. If you're on Twitter, that is. Just DM me your email address, your physical address, and we can get this sent out to you. If you don't have Twitter, pipe up in the comments, and I'll figure out another way of getting your address to me. So congratulations, Kevin. Thank you for commenting. Yes. Wow. Exciting. There we are. Kevin says, yay, we have a kiddo. Great. Awesome. Perfect. Well, we've got a nice box of stuff coming.
PCB art.
Yes, please.
So we were showing off that original Lixie board.
Ooh,
so this back and these designs here, this is actually hot air solder leveling for the letters, and then the silk screen for the white. I was going for kind of an art deco, kind of a
I was going to say, it does look, yes, absolutely.
When they're done. So I wanted, and it was just lucky enough that it is a one-sided board design, so I can have all the copper design I want on the back.
Yeah, stunning. Really beautiful. Then, I was going to say it's quite art deco.
Let's see here. This is a product that we wanted to release before the chip shortage. It was the Pixie Universal Enclosure Kit for the original Pixies or Pixie Pros. So this is actually, I don't have it screwed together. Let me take it apart. Let's tear down.
That's what I love to hear. You're saying sweet words in my ear,
there's
Connor.
Some populated Pixie boards back in there.
Ooh.
So 6 Pixies, and then this board with bodge wire. Uh-oh.
We love a bodge wire.
Some automotive wheel weights. If you guys have never used these, they are self-adhesive. They're ½ ounce each. And if you want to add weight to like 3D prints or like inside a product, they're awesome. Just make sure not to.
What are they called?
They're automotive.
To the camera?
Yeah, they're automotive wheel weights. I don't know. I'm not a car guy.
Wheel weights.
Yeah, I think they're used to balance tires in the same way you balance like ceiling fans. You can buy weights for them.
Yeah,
Get them on like Amazon. It makes it feel a little heftier,
a little chunkier, a little more like you're getting the correct amount of electronics for your money. So I don't know what it is about weight.
There's some odd stuff over here that I've done before. This is not an ESP8266 surface mounted to this PCB. It's actually on one of those Wemos boards I was showing you earlier, whose pins have been surface mounted, like reflowed without headers.
Oh my goodness!
Down to square pads, which works pretty well. You've done
an SMT, like an SMD little microcontroller. It's hilarious.
Yeah, I did like a what do they call it? Like a chip on chip kind of thing, like the old Raspberry Pi with the CPU and the RAM. So and then 6 slots for the not the Chromas, just the original Pixies, and then 3 buttons up here. So when it goes into the 3D printed casing here, you get 3 clicky buttons.
Nice. Very
Let
nice.
me actually reclaim.
I can see why this wouldn't have been suitable for like mass production, though. You know,
Yeah,
it's a
it's
lot more
definitely this was
fiddly.
more limited run.
Yeah. Whereas the Pixie Chroma, you can just like print it essentially.
This is my girlfriend's business for one of the shows she did at her table. We set up a little sign for her.
Nice. That's so clever. I love it.
And these are
really nice.
Hand place 0402s.
Wow. Wait, you hand placed those?
Yeah, it took a long time.
Why? Do you hate yourself that much?
I do hate myself. That's correct.
You needed one of Robin's pixel pumps.
Yeah, so PCB art-wise, this is another use of a copper plane with just an eagle. It's called like T-stop or B-stop if you're on the bottom, where you can just pull away at the solder mask to reveal text, and you get a nice kind of glossy silver text to it.
Super sweet. I like it. That's delicious.
Designed right before everything was about to go wrong.
Oh my goodness. Oh my goodness. Yes. Beautiful.
Somewhere here. I don't have time to find it. I'll put it on Twitter later for those of you who
can put it in the show notes for the people. People will watch it more afterwards as well. So if you just if you send me some links, I can chuck them in the description afterwards as well. So do take a look down in the description if you're watching this after the fact. We can do that. Awesome. That's really great. And actually, I really want to hear a little bit about manufacturing, because I know you've had some. This is your first time doing like a big mass-produced thing. Everything's been hand-produced before. You've done your own 3D printing. You've placed your own LEDs, all of this stuff, and now this product you are sending it out. You are having it assembled by other people, and I'm really curious to hear like what your experience has been and how you found it to move from what I'd call more like project level stuff, like more DIY kind of handmade stuff, up to more like a project. So share some of your journey with us, please.
So sending off an order for 77,000 LEDs to get placed is terrifying.
I bet.
You will not sleep. Here, let me grab the bin real quick. And this is not the bin of all of them. So I've got, I don't know if you can see it in the frame, there's several of these little bowls that have 100 each of chromas in them. But the bin of everything that didn't fit in the bowls, it's a lot of Pixie Chromas with 70 LEDs a piece. So, this, which by the way, this is me vouching for PCBWay's like assembly quality. This is our bowl of dead ones. That's it.
Oh, that's not bad at all.
No,
that's actually not bad.
10. It fits in my hand. I ordered 1,100 PCBs, and these are the dead ones. So PCBWay is pretty good about that. But what we did not account for is a former U.S. president making new rules that I forgot about those new rules. Tariffs.
Tell me about those rules. The bane of people with COOs in China coming into the U.S. Yes.
Everyone on Twitter told me about it afterwards. $800. So apparently $800 for this type of work. I don't know about other types of imports, but for like PCBs, above $800, you start to pay, I think it's like a 25% tax on everything beyond that. So our like $6,000 order of boards got taxed 25% at the customs. So it left China through DHL correctly. It got to, I think it's Cincinnati for DHL. And then it just sat. And then you check the tracking number and it says, customs duties need to be paid. And I'm like, oh, okay. I never had to do that before. I hear all the time, Europe has to do this. Let's see. And I click onto it. I'm like, it's $1,600? The shipping cost was only like $200. So that was unexpected, but Crowd Supply actually helped us a lot with our budgeting going into this to make sure that we had enough of a buffer afterwards so that we can account for unaccounted things.
Yeah.
So that actually didn't halt us really at all.
I'm glad to hear it. I'm glad to hear it. And how far are you away? So like you've got everything in boxes, you're testing. How far off is it, do you reckon, before you're sending your boards out into the wide world?
Yeah, we just got a Staples delivery today for labels for Crowd Supply.
Yes.
And we've got our bags.
I've got
like 5 big Uline boxes of bags sitting over there. So hopefully the last thing we have to figure out is CE/UKCA compliance. And we're still working with Crowd Supply. It's some legalese and we're getting used to it. So I have to make
the
changes
CE
there.
Stuff. Yeah.
Luckily, the UKCA thing is new enough. It's all the same as CE for the most part.
Yeah.
That'll get worse over time.
It will. It will get much worse over time. Yeah. I know. I believe me. I left the UK for Germany when it happened. I was like, bye. Bye.
So,
ridiculous.
Other than like the UKCA and just packing these up, these are already tested. Which was
how exciting.
Do you want to see our cute little testing jig? I showed this off on Twitter a while back.
I love your testing jig. Look at this adore. I'm gonna spotlight you.
So it's got little paw prints.
Oh my gosh! It literally has paw prints. Oh my goodness, that's adorable.
Okay, so let me demo how this works. We're gonna.
And is this a jig you've made yourself? Is that 3D printed case or what is that?
Yeah, so this is
layers of acrylic.
It's a FDM printing on the bottom and resin printing on the top.
Oh, nice.
So when I plug this in, it's gonna have some little blinky eyes. And he'll just sit there. He'll kind of look around. He'll wait for an order. And let's take this board. And let's hope this board is good. That'd be so awkward. We're gonna stick it on the pogo pins on the top. And it's going to individually run through lighting up each channel of each LED. And what it was doing there, and then the chroma on the front has a big old check mark. What it was actually doing there is watching the voltage drop for each channel of each LED and comparing it against a known good value. So that way, if one of your sub LEDs is dead, like you only have a working green and blue on one, it will, the little speaker, it'll go bam, 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 and it'll put a problem on the front of the display there. So let me grab one of these supposedly dead boards in the bowl, and we'll see what it does.
I love the fact it just looks around and blinks while it's waiting to test. It's just the cutest testing jig I think I've ever seen in my life.
I think this one, I did have one board that just did nothing. So let me grab another one so we get something more interesting going on.
Ooh, Kevin's asked if the testing jig has a name. Is it employee number 3 of Lixie Labs?
I haven't even thought about that. So let's take a name from you right now.
Yeah, what should we call it? And Kevin's also asked how a jig knows if the new board is plugged in. It's because the pogo pins make contact, right?
Yeah. Oh, okay. So here's a good example. This DX here, this is actually all the LEDs passed, but data continuity from the last LED to the output pin, which isn't something you would see if you were just putting it on and seeing if they light up. So continuity between the last LED and that output is bad on this. So it actually is watching for continuity between the data in and the data out pins on here. So when you stick a board on these pogo pins, it'll automatically start the test. You don't have to hit a button. Yeah,
fantastic. So, it's the best testing jig I think I've ever seen. Timon says he loves that jig. Oh boy, who doesn't want to see a testing rig? It's amazing. Oh, and Leon and Abby joined us. Hiya, Leon. Nice to see you. Yes, always lovely to see that you're out and about. Awesome. I love your testing jig so much. It's super cool. And so you're nearly ready to post that, but you got let me just bring myself back in. Here we are. I was just looking at you, thinking, chatting away. So you're nearly ready to send out the backers orders. Did you get enough made to also send out all the pre-orders that have come in and build yourself up a stock as well?
Yeah. So we had about 150 extra beyond crowd supply. And then I myself have a few hundred bare boards and a couple reels of those LEDs. So I can always, if people need replacements and I don't have the professionally assembled boards, a professional can assemble them for you on the spot.
Yeah.
Because if I can use those 0402s, then I think I'll be able to do
it. Yeah, because we, like, Crowd Supply ordered a bunch as well, didn't we? So we for those of you that don't know, when a campaign is successful on Crowd Supply, we place a large order ourselves, usually like 50 to 100%. I don't know how many we bought off of you, but yeah, we liked it because we continue selling them really at Mauser, right? Yeah, good. Well, I'm glad.
It's like a 401k. They're going to match contributions.
Yeah, exactly. Match contributions. Well, also, like for us, it's not just about the crowdfunding campaign itself. It's about the longer tail of sales, because it's not just like a one-off event, right? So that's really interesting. And then where are you planning on taking this after it's all? Are you just planning on just going on holiday and never thinking about LED matrices ever again for 2 weeks? Or like what are your plans?
I actually, as soon as our campaign finished, to the point when like the very first stuff started to arrive for fulfillment, I just took a mental I am doing nothing break because for anyone who hasn't seen it, we did a CGI ad too. I started on that in August.
It was amazing. It was like, it came in, I was like, what? This looks like real pro quality. Like the ad was incredible.
So from like the end of July all the way to like January 5th, it was like kind of a daily thing for me, writing code, getting documentation, designing the boards, getting my prototype in. So I took a month between, campaign end and when the orders finally started to arrive, all the pieces started getting here, where I'm just, I'm
very, very happy to hear it. More people should follow your example, because that's the way that you don't get burned out by doing this thing. Because I think sometimes it's like, carry on, more, quick, but like actually longer term. And I'm saying this as somebody who did have like terrible burnout, but it's really important to have those breaks and to make sure that you're caring for yourself, because otherwise you can't carry on doing awesome stuff. If you destroy yourself in the process.
Tells me all the time.
She is correct. She is correct, and I'm glad to hear it. And what are your plans for the future for this?
I think I'll definitely be able to like fully rest easy once the very expensive order of boards that I paid very expensive taxes on is successfully delivered to Crowd Supply. That's another like, I'm losing sleep on it.
When they get to Texas. So again, for those of you that don't know, it's like So it's because Crowd Supply used to do that in house, but because like since we got bought by Mauser and then integrated into their systems, now Mauser Electronics does all of the logistics and distribution and sending it out and so on.
They're good at that.
Which is quite good. Are you glad that you don't have to put labels on envelopes?
Even just on like medium tindy orders where we were doing like 50 to 80 units, sometimes I'm like, I never got myself like a label printer. I just have a printer. So I like slicing out labels and taping them on. And
no. Yeah, the whole logistics side. Yeah, no, it's terrible. I'm very happy that Mauser does it for you.
And going forward, we're looking to probably put these on Tindy. They'll be in like smaller limited runs because we'll be doing them ourselves. They won't be a big order like this one was. And then talking
many
to
people who do Crowd Supply, many people who do Crowd Supply do Crowd Supply and Tindy afterwards. So they'll launch it on Crowd Supply and then continue to sell on Tindy. It makes sense. It's like a nice, recurring stream of things. And you've got to expand, because of course, you're going to get it stocked by Adafruit. You say that would be really cool. Have you been in touch with P-Maroni as well? They're like the British Adafruit. I think they've loved this.
Yeah, they've reached out to us. We're really bad at replying.
They're really good people. They're really nice people.
I've never actually heard it out loud.
P-Maroni is Pirate Robot Monkey Ninja. P-Maroni.
No way! That's what that means.
Yeah. That's true.
I always wondered. Okay, cool.
In fact, Paul, who's one of the founders of P-Maroni, is the person who introduced me to my husband.
Oh wow!
At SuperCon in LA, yeah. So
that's really cool.
I've got a lot of love for P-Maroni because they're responsible for my marriage.
P-Maroni. Oh.
Yeah. Oh, funny stuff. Yeah, I do want to see it everywhere. Yeah. Awesome. Yeah, and of course Mauser,
Mauser,
which is great. Is it exciting to see other people selling your stuff? Do you feel like you're losing a bit of control, or are you excited to see it?
That was a big fear going in, because I've done this almost completely solo up until like the last year, and I've had full to the graphic design, to the color of the footer on the website, to the exactly pixels lined up. So it's really scary to get so used to that for so many years, and then fully bring in a partner to it, and then outsource some stuff, and
you lose a lot of control.
If you want to share screens again real quick,
I could do that
to help ease our minds for our big PCBA order we did. Let me pull up Twitter here. Oh, I'm not signed in. It's not my computer. Okay, well, basically, we'll just go back to me. Yeah, one of our
I'll pull up your Twitter.
Was it was a PCB orientation diagram we made for PCBWay that basically says like the little die inside the LED faces left when the gold arrow on the PCB faces up, so that from any direction you'll know exactly how it should look.
Is it on your
should be under
share my screen, because I've got your. Here we are. Oh no, that's not what I meant to do. Let's do this. So is it on? Can you see this now?
I can see this, yeah.
Okay, good. So media. What am I looking for?
I think we're on my screen. I think. Am I? Yeah, that's mine.
This might. What's? Oh, hang on. Oh, we're on your screen. That's because I'm an absolute idiot. I have not shared my screen. I was sharing your screen. Oh my goodness. Let me try that again. I was like scrolling down. I know. That's what threw me.
That's awesome.
Here we go. So,
yeah, but anyways, we did a little graphic design to help PCBWay, and we attached it to our order with like an imager link and the zip file of exactly how the LEDs should go, so that if there's any issue with your Centroid file, your PCB assembly file, but you know personally how it should look when it comes out, you should always make diagrams and send them along with. And that way, if there's any problems, they don't just trust the Centroid file and put it in wrong. They'll know exactly how you pictured it.
Is this it?
We're close. Yeah, if you go down a little bit more in the pictures. Let's see. Almost. Shout out to Tiny S2. That's an awesome microcontroller. They're right there.
Oh wait.
So this is our diagram we sent along.
Yeah.
So yeah, LED die faces left whenever the gold arrow in the center here faces up.
Nice. So you design that in. That's really cool. Awesome. Well, we've gone like way over time. Somehow we've been talking for an hour and 8 minutes, and we're supposed to talk for an hour, but that's fine. But I've got to go because my parking's going to run out soon. Oh, no. Yeah, I've only got 2 hour parking around the office. But it's been an absolute delight to talk to you. We've got some final comments as well. So who we got? Let's say we've got Oh, that's cute. So Kevin suggested Testy or Inspector Lixie.
I like that.
Inspector Lixie. And Timon says, I'm all for Inspector Lixie.
Yeah.
Or this one, Quality New Engineer.
New Engineer.
That's cute. And Deshipu also says, we need to see more cute jigs in this industry. I agree.
Oh, yeah.
I fully
Quick
agree.
tip for anyone with testing jigs. If you ever wondered why a lot of them have clamps, it's so your fingers aren't freaking broken by the time you've done 1,100 boards. Clamp.
Next time, are you going to do one with a clamp? Yeah. Clamp. Get that clamp. Get that clamp involved.
Really small
Otherwise, you're
on this too, and I have to see all the LEDs, so I'm doing like 2 fingernails on the corners.
Oh, broken. All right, Connor, it's been an absolute delight to talk to you. Thank you for showing us around your board. Thank you for telling us a little bit about your journey and sharing lots of really exciting blinky LEDs with us. Yeah. I am going to be back next week we're getting a behind the scenes tour of Protopasta, which is local to us here in Portland. So Protopasta is a 3D filament printer, a 3D filament creating company, and as they're quite local to us, I've invited them on the show so we can have a little look behind the scenes and see how 3D printing filament is made in a proper factory. So a little slight departure from the technical world of hardware, but I think it's going to be very interesting to have a look inside. So do join us for that if you have an interest in 3D printing. For now, though, I'd like to thank everybody for joining us, and especially our guest today. Please go along and make sure that you are following them on Twitter. That's Lixie Labs or Lady Lixie Labs. Pre-order on Crowd Supply. Take a look at the code on GitHub. Before we sign off, Connor, is there anything you wanted to ask for help from the community, or advice, or any upcoming events that you want to shout out? Is there anything you want to promote or ask for before we leave?
I think I'll do a little bit of promotion, and I'll ask anyone who's interested in Pixie Chroma to take a look at our GitHub. Take a look at the Arduino library, because we have a whole bunch, like 3 folders worth of examples that come with it, and see for yourself if it's something that you're comfortable working with, because it's meant to be super easy. But if you're curious if it does something really technical, you can take a look. You can dive into those that generated software documentation we were showing, and you can see just how powerful it can get. Because a lot of the value lies in the work we put behind, just like a Prusa Mini. A Prusa Mini is kind of simple on hardware, but it's all the work they put into that software that makes it run awesome. So
yeah. Amazing stuff. All right, cool. So anybody who is interested in helping out or curious to see behind the scenes, please go and take a look at the docs and the libraries examples on Connor's GitHub, which you can see right there. All right, so without further ado, I think that is it. Thank you so much for joining us and sharing so much good knowledge. I particularly enjoyed learning about the power line in the FastLED library. That's a tip that's going to stay with me for some time. Yeah, really great. Nice little bit of functionality that I did not know existed. So thank you so much for sharing that and your cute little test jig. It was really nice to hang out with you, and we've got like matching electronics tattoos as well, which I've learned today. That's cool. Wrong side. So really nice to see you, and I'll speak to you again soon. All right, thanks everybody for joining us.